This project aims to recycle helium. This provides a cost saving to the university, but also recognises that this is in scarce supply and is a non-renewable product. We are therefore extremely pleased that we're able to use simple technologies to make a difference in this world.
Helium is a very, very cold liquid known to man. It's at minus 269 degrees centigrade.
Helium is used for research purposes. Some of it is used in body scanners for its medical purposes. The other research is for low temperature physics with microchips and drug research for things like cancer and Alzheimer's.
Helium actually is not a natural resource and has to be processed from things like natural gas.
The amount everyone's using, it will actually sort of expire in 2050, but if we can conserve it at the rate of 80 to 90%, it should last another 100 plus years.
If you go back to about just over 3 years ago, there was an abundant supply of helium to the university and other institutions like ours. But the problem arose with maintenance problems within the Middle East and in America, and we were put on a severe shortage.
Other elements on the campus were buying in about 25 to 30,000 litres of helium a year. They just throw it away. It went through the experiment. Helium is lighter than air. It just floated away to join the other helium that exists in space.
So we devised this project to try and catch the helium gas that was going into space, going into atmosphere, and basically we want to try and make ourselves self-sustainable. We
decided to capture the helium by using underground pipe work and portable gas-packed trailers where we couldn't put the pipes.
So once those trailers are full of helium gas, I actually decant that gas into my system and re-liquefy it for reuse. So they are able to actually use the helium is captured at that specific unit, and then actually it's just blown back to the liquefaction plant into a collection bag where it is recompressed and put into big cylinders and then re-liquefied and then used again. And then the actual liquid which is produced is supplied to the users again, and they use it, and then the gas comes back to us, and it is just a total recycling.
So we hope to collect about 85 to 90% recovery from the usage in those research groups.
It can be run as a 24-hour operation, but there are benefits where we can actually run it under cheap rate electricity. So we're able to run the actual liquefaction plant during the night when we take benefit of the cheaper rate electricity supplied to us.
There used to be a liquefying plant here since 1964, but on a very small scale. That was just basically for physics. This now has expanded it and brought in the different schools and faculties within the university.
In our position, this project actually is protecting around about £8.1 million worth of experimentation equipment. So this will prolong the research within the university and offer more benefits to our students that come here and study physics.
We've generated a lot of interest. We've had forums here where they've had seminars and they've actually been to visit it to actually look at replicating this in their own universities and industries. We also use it in arc welding. NASA use it over in America to actually clean the rockets and in their labs as well. So the system is really, really expandable. If people take more care now, we can sort of protect the future, and hopefully within the sort of 50 to 100 years it could last longer. We refine new technology